Hey everyone, this is the video for Unit 6, Lesson 15, where we'll be able to determine dimensions of scaled figures. So the thing about it says the square to the right has side lengths of 2 inches. I'm going to write that right here so that I can see it. 2 inches, and we know a square has all equal sides. Step A says determine the lengths of the square and draw it if the side lengths were 50% as large as the original, while step B says determine the lengths of the square and draw it if the side lengths were 150% as large as the original. So I'm going to make a prediction here. I'm going to make a prediction that if the scale factor is 50%, since it's less than 100%, it's going to be smaller. Okay. And if it's greater than 100%, I'm going to make a prediction. It's bigger than the whole, right? It's bigger than the original, so our image is going to be bigger. And all sides are equal. Great. So determine the lengths of the square. We have our original is 2 inches, and we want to find 50% of 2 inches. So 50% of 2 inches, that would be 0.5 times 2, and we get 1. So 1 inch is our new side length for this guy. And for this one, we're trying to find 150% of 2 inches. Do 1.5 times 2, and we get 3. So 3 inches. Okay, so what do we think? Was my prediction correct or incorrect? So what do we know about scale factor in relation to 100%? For example, if the scale factor is less than 100%, we'll get a increase or decrease? Decrease. And if it's greater than 100%, we get an increase. So let's copy this down together in the key point box. Ready? Applying a scale factor. Applying a scale factor greater than 100%. Enlarges an image. And less than 100% shrinks an image. Fair enough. It's also called a reduction if it's smaller. Okay, so now that we have the key point, we can definitely move on to the interaction with new material. So let's scroll down. Okay, it says on the grid of squares below, okay, it says on the grid squares below, construct a figure that is a scale drawing of the given figure by applying a 225% scale factor horizontally and a scale factor of 80% vertically. Okay, this is a lot of information here. So what we need to do, we need to figure out some measurements, right? Let's start with horizontally since that's the first one that it gives us, right? So horizontally, how can we measure this horizontal line? From here to here. What I'm going to do is I'm going to count the boxes. So watch me, we go 1 box, 2 box, 3 box, 4 box, 5 boxes, 6 boxes, 7 boxes, 8 boxes. So this is 8 boxes. Let's say 8 units. Okay. And you know what? Let's do the vertical one now too, so we can finish measuring. Okay, let's count the boxes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. 20 units. Okay. So it wants us to apply a 225% scale factor to the horizontal side. So I know for scale factor, just like we did for the think about it, we're going to do what? We're going to take, let's label horizontal first. Horizontal. We have 225% of 8, which is then 2.25 times 8. And let's see what we get. Plug it into the calculator. Get 2.25 times 8, and I get 18. So let's start kind of close to our other one, our rectangle, so that we have enough room at least. Let's start right here. We want to go 18. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's our horizontal figure. And I don't think we're going to have enough room for, let's see. Maybe we will. Let's see. So this is our horizontal now. Let's go ahead and make a line here. And then for our vertical, the scale factor is 80%. So vertical, we have 80% of what? 20. That would be 0.8 times 20, which I know equals 16. Oh, whoops, this one equals 18 units. Okay, so let's go ahead and go down 16 units. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Now I'll make my line. Okay, so now I can go right across here as well. And down this way as well. And that would be our new figure. So let's look again at the key point to make sure that we did everything. It says applying a scale factor greater than 100% enlarges an image and less than 100% shrinks an image. Now, how does that apply to this one? I mean, it made it much larger. I see. It didn't make it longer though. It made it horizontally larger. We have 18 units up here, and we have 16 units down here. Does it make sense? I think so. It's shorter, right? Because our scale factor here is only 80% for vertical. And then it's longer because here we have a scale factor of 225%. So let's go over the criteria for success so we can do this right every single time. So the CFS says that we, of course, number one, annotate the problem. Annotate the problem for the scale factor. And its effect, meaning if it enlarges or if it reduces or shrinks. And number two, we determine the corresponding side lengths. So for example, corresponding side lengths here are horizontal ones. Then another pair of corresponding side lengths are the vertical ones. And number 3, we show or draw the enlarged or shrunken scaled figure. And that's the criteria so that you do it successfully every single time.